Questions about 1.2, right? Linear equations in one variable. A little bit of everything. I gave you a different assignment, multiples of 3. Yes. 63. Okay. A little bit sloppy, but here we go. Problem that had algebraic fractions in it. That's 66. I got 63. I picked the wrong one. Thank you. No, thank you very much for doing that. Okay, here we go. I think I got the right one now. 63. Algebraic fractions problem again. I still think the best advice is find the least common denominator for all the denominators on either side of the equal sign, which in this case is 3 times the quantity 5x plus 4, and then multiply both sides by that. Well, another way to do it, when you have just 2 fractions equal, you can do the cross multiplication technique. It comes out the same. So that gives us 3 times the one on the top left equal to 2 times the one on the bottom left. Now, what I'm not showing here, and I really, if I was a good student, I would have checked this right away, right below it, and probably because I did this in class or something, I didn't take the time, but I really, when I collect your papers, which is going to happen, boy, if I see checks down here, that's awesome, because then you know for a fact if you got it right. Is that enough info for 63? Yes. But 84 is the one you picked. Okay. I got 81 here. Let's do 84. Okay. So 5 plus ax equals 12 minus bx with what kind of directions? Solve for x. Okay. So just like in any other problem, this one, even though this one's got a unique, I know the a and the b are the challenges, right? But don't we still follow the same principle, which is, let's get the x guys on the same side of the equation, and then let's take it from there. In my case, I would prefer to add bx to both sides, giving me and then I would subtract 5 from both sides, giving me, and now comes probably the part where, I don't know, maybe had a little bit of a slowdown, and that is factor. Because you've got to get that x by itself, right? So factor in this case, x is a common factor of that binomial term. Now, don't I just want to get rid of a multiplied a plus b, and therefore I can divide both sides by the quantity a plus b. And this one's a little bit harder to check. I really don't want to take the time to do that now, but something like that, does that make sense? Other one to look at? Yes, go ahead. 57. All right. Whoa. Not sure what happened there. All right, 57. Okay, 57, we have 4y minus 0.75x plus 1.2 is equal to 0. And our directions are, find the x and y intercepts algebraically. Okay. Well, so let's just say I'm just gonna, abbreviate. Let's do part 1. Let's find the x-intercept. To do that, we're going to set y equal to 0 and solve for y. For x, excuse me. So what do we get when we set y equal to 0? We get negative 0.75x plus 1.2 equals 0. And it's very easy to solve for x. You could subtract 1.2 from both sides. It's supposed to be an x. And then divide both sides by negative 0.75. Where's the 4y? Maybe you didn't see what I was doing. I was finding the x-intercept. And when you find the x-intercept, you set y equal to 0. Well, when you set y equal to 0, what's 4 times 0? That's why it's gone. So anyway, finishing this up, I'll let you finish it. You'd have to do this calculation. Okay? And that's going to be a positive, and you can simplify that. Then part 2, y-intercept. This time, you set x equal to 0 and solve for y. So when I set x equal to 0, I should get something like this. And then when I subtract 1.2 from both sides, divide both sides by 4. And what is that, 0.3? So now, I by the way, when I'm all done, whatever this x, let's finish this up. Negative 1.2 is what? Negative 1 and negative 6/5. That's negative 6/5 divided by negative 3/4, which is times negative 4/3. That cancels. You get 8/5. So the x-intercept should have been 8/5, comma, 0. And down here, we got negative 3/10. So the y-intercept is 0, comma, negative 3/10. So then we've completed the problem. We found the two intercepts. Make sense? Another one. Yes? Sure. Let's see what's happening there. 78. Okay, I got this one written out. Solve for x. You're going to have to excuse, I have a couple things crossed out. Make believe they're crossed out, not crossed out at the moment. So first we have to square that x plus 1. That becomes a perfect square trinomial, right? X squared plus 1, and then you got the middle term, 2x. And then I multiply out this distributive property, and I did the handshaking over here. Got that. Okay. Now I got all these wonderful things. What I did in the next step is I subtracted x squared from both sides, and that's what allowed me to scratch those out. And then I just combined terms from here to here. 2x and 2x is 4x. Negative 1, positive 1 plus negative 4 is negative 3. and have that left over on the right. Now let's get all the x's together, add x to both sides. Get rid of the 3 by adding 3 to both sides. Divide both, finish it up. You're welcome. Yes?
For number 96, for like, could you process, like, I solved for B, and I got the answer to that one, and then for C, I just put in,
Wait a second. Did you say solve for P?
I guess it's C, or for B.
I'm wondering if I'm on the right page. I have totally different letters in my book.
No, and like solve for letter B, like,
I don't have a P. That's what I mean. Is yours the one about tax credit? My equation says T equals E plus S.
no, I mean for like A, B, C, D.
Oh, I gotcha. Sorry, I'm so good. Okay, got it. So letter B, find the earned income each. So I got you. So if the subsidy is 6,600, that's the S, right? And have they given you the total? No, they just say.
No, then I solve for E.
So you solve for E.
Yep.
Yep.
Then for letter C, don't you want to put the 13,800 in the C equals B plus S?
Yes.
So then you got 13,800, or 13,800 equals B plus S. And then
I see what your question is. Let's see. Well, there is other information up there. They do tell you something about S and E in the relationship. They say S is 10,000 minus a half of E. So we could make that, we could get rid of the S completely and now have it be T equals all E stuff.
I was just wondering if that, if they want us to put the.
My guess is they probably want you to make use of that substitution also, and not just do the beginning. I see what you're after now. Boy, it took me forever. Sorry about that. I thought we had different versions of the book or something. Okay. Yes. 87. All right, let's see if I got this right. We've got this expression, and you're supposed to solve for x. Okay. So, a little distributive property to work on in the first line. Then what I did is I know there's actually 3 x terms up here, but at least I got the what? The plain x terms together by adding 4x to both sides. So that got me down, and then I wanted to get just the x guys by themselves, so I got rid of the 18 by subtracting from both sides. And then, finally, how do I get that x out of there? Again, the key is factor. And then you can divide both sides by that big old fat multiplied number. By the way, you've got to be careful here not to just think of this as a... Normally, when I see a negative divided by a negative, I think, oh, that's a positive. But that's not so simple here, right? Because if there's not just one number on the bottom, so I can't just cancel a negative 1. You know, this negative is actually, this negative 1 out here is not a factor of the whole thing. And so, now the book might have written this answer like this. It's possible, I don't know what they did, I didn't look, but it's possible they might have gone like this. Where they factor a negative 1 out of the whole denominator and then cancel them. So both of these answers on the bottom would be correct. Anybody look in the back? I'd just be interested. Which one?
It's 10 minus 2A
Okay, so they really have this answer. I was wondering if they did this sign thing, but evidently not. Okay, thanks. All right, any more from yesterday? Maybe Heidi, you haven't had a chance yet. 108. 108? Okay. All right, 108. Oh, multiples of 3 means, keep going until you run out. Okay. Did I hear somebody say that we have to go that far? All right, well, anyway, 108. So our problem reads x squared minus 49. That should be ringing a bell in your head. That's a difference of 2 squares, right? And on the bottom, we have this kind of ugly thing, x cubed plus x squared. But hint, 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 it has 4 terms. I'll bet that's a divide and conquer guy, right? Those 4-term guys very frequently turn out that way. So already, as I'm writing on the problem, I hope some of those things are striking you. So on the top, we already know what to do. Difference of 2 squares, so we got that factored. And by the way, they said simplify. Well, really, your only hope for simplifying an expression like this is some kind of factoring and cancellation. So on the bottom, let's do the divide and conquer thing. So let's see, what can we take out of that first part? An x squared, right? Which leaves us with a x plus 1. And then out of the second part, we could what? Take a 3 out, which doesn't look like it helps a whole lot, does it? Too bad. Anyway, that would be an x minus 7. Now that's really a downer, which means the way I factored it, we didn't really come up with anything that led to factors, because right now the way I did it, here's what we come up with. No, we can't even factor that bottom, can we, the way I did it? Because we have no common factors. All right. Is it possible that I could have written that a little differently and gotten a different way to factor that? Like, could I have rearranged these terms at all? By the way, did I copy this right? Okay. It's another thing I always got to check. Sometimes I'll waste 30. Have you ever done this? Or you waste about a half hour on a problem, you realize you didn't copy it right? Yes? I don't see why not. Sure, I'm just taking them to it now. Now, let me just say, in this case, what I did is legal. Did it lead to any factoring? It would have had this factor turned out to be the same. It would have been cool. I could have then factored it. So it kind of led to a dead end the way I did it. But I did it. Yeah, it's legal. It just didn't lead me anywhere. Now, what I was wondering is, if I rearrange these, would that help a little bit? Not really. So, right now, what this is showing me is, I don't know if this can be simplified. I'd be interested if they found a simplification for it. Did they? Did anybody look? Oh, this is not a multiple of 3 either, is it? Or is it? Oh, if it's an even, so we don't know. I would, honestly, my answer to this, I don't think we can simplify it. Is there anything wrong with me, like, copying this denominator right down here and just leaving the numerator factored? You could do that, but I really haven't simplified it. So, this is not one of my favorite kinds of problems, because it kind of gave you the idea it could be simplified, and then they were over in the corner going, nah, you couldn't do it. I don't know. I don't get a real thrill out of those. It's kind of like the old multiple choice, none of the above. Kind of that'll leave you a little bad taste in your mouth. Does with me, yeah. So anyway, does anybody see? I might just be looking past. Anybody see a way to factor that? I don't think it leads us anywhere. So, all right, let's get started. Excuse me. on 1.3, modeling with linear equations. The title and the 4 learning objectives today are using a verbal model and a problem-solving plan. So probably dealing with some word problems, everybody's favorite all the time. Secondly, more emphasis on word problems. It says writing and using mathematical models to solve real-life problems. This is always a big one, solving mixture problems. And number 4, using common formulas. I suppose that means maybe what? The circle formula, the Pythagorean, things like that to solve. So there's a lot of emphasis on problem solving here. Now, yeah, this looks like a bunch of miscellaneous garbage, but I'll tell you why this is up there. I took 2 pretty commonly used formulas and put them at the top of 2 columns. On the left, I have d equals RT. That stands for distance equals rate times time. A real common formula that's used all the time. So if you take your speed, you know, if you're going 50 miles an hour in your car, that would be your rate, and you multiply it by how long you travel at 50 miles per hour, you should be able to tell how far you would go. So if you go 50 miles an hour for 5 hours, you should go 250 miles. And then this one you probably, here's another common formula, maybe you recognize the area of a triangle, base times height divided by 2. What I'm trying to show up here is that, well, I don't know how well I did it, but sometimes what has to happen is you have to, instead of solving for d, which this formula is real nicely set up for, what if you only have, what if the only thing missing is t? Well, can't you take this equation and divide, you know, do some algebra to get down to t? And so a lot of times you're going to have to take common formulas and maybe solve for a different letter. Let's do, let's see, I'm trying to think of another one. Yeah, here, let me throw another page up here, and let's take another common formula like, you probably recognize that one, the area of a circle, pi times the radius squared. Well, what if you had the area, but you wanted to find the radius? In other words, I'd really like that formula to be solved for r. So let's just do that. How would you solve this for r? Well, you want to get it alone, so I don't want the pi there, and pi is being multiplied, so we could divide both sides by pi. That would put us in this position. Now, how do I get r to be just a plain r? Take square root of both sides. And now this is important. Whenever you decide to take the square root of both sides, you have no choice. You have to take both of them. Always take both square roots. There's always 2, right? The square root of 49, there's 2 of them. 7 and there's -7. And so this is important that you remember both. So then, this is as good as we're going to do. We got r down. Now, I know radii can't be negative, but still, it's really important in algebra that whenever you take a square root, make sure you take both. Okay. Then we're going to have problems of this type, where you have half English and half math. Like, what is 30% of 45? And how do I translate that into a math problem? Well, actually, this one's really easy. You can almost do a word-for-word translation. What x is equals 30%, 0.30 of multiplication 45. That one's pretty simple. And in this case, I have a really easy problem to solve. I don't even have to get x by itself. I just have to do that multiplication problem. Or here's a different one. 70 is 40% of what number? 70 is 40% of what number? And so this is literally a word-for-word translation. Now, here we do have to do a tiny bit of algebra. What would we have to do to solve for x? Divide both sides by 0.40, and then you'd be off and running. Okay, so this is just giving a hint. When you do word problems, some of them, you can actually do a word for word. Not all of them. Okay, now this is problem number 32. Let's take a look at it in the book. I believe it's 32. Let's take a look. Yeah. Okay, now this one takes some thought. It says one positive number is 1/5 of another. The difference between the two numbers is 76. Find the numbers. So one number is 1/5 of the other. So I just said, all right, well, let's call one number A, then wouldn't the other one be 1/5 A? Now, what you don't want to do is say, I want to call one number A and one number B. If at all possible, stay away from multiple variables. There's nothing wrong with that. It's just that then that means if you're going to have two variables, you're going to have two equations, and the problem gets a lot more complex. It just takes longer to solve them. It can't be done. So you notice I stuck with one variable. A and 1/5 A, which you can also just call A over 5. Now, the book says, hey, the difference between the two is 76.5. So all I had to do is set up a subtraction problem between the two problems. And by the way, it should be obvious which one is bigger. Doesn't A have to be bigger than 1/5 A? Yeah. So I knew it had to be set up like that. Then, boy, I really wanted to get rid of this. So what I did is I multiplied through by the least common denominator, both sides of the equation. That gave me 5A minus A equals, and then I also had to take, 5 times 76. And then really it wasn't very hard after that. Now when I got all done, you got to be careful. You get all done, you're really happy, you got 95, you say, got it. Did I really? Because the book said find both numbers. I really only found one. So, all right, well, if A is 95, the other number is just 1/5 of that. And then so to find the other number, I have to divide by 5, and I get 19. So what are my two numbers? 95 and 19. Now I got it. Here's another sample from the assignment, number 39. 12 is 1/2% of what number? So I did it. Yes. I sure can. Where did I get the what? The 76, I think it was just given in the problem.
Okay.
They said that the difference between the two was 76. Yeah. By the way, that would have been the other way I could have found the other number, right? I'm glad you brought that up, because divided by 5, I get 19. What happens when you take 76 from 95? You also get 19. So I could have done it. Actually, I had two ways to find the second number, right? But don't quit. Common mistake. People get down here, they hit the 95, they go, wow, am I good? And they go on to the next problem. And they didn't just go back and look, hey, did I answer the question? Ooh, not quite done yet. So make sure you just take a moment to go, all right, did I answer what they asked? 39. 12, the book says, is 0.5% of what number? So we do our direct translation. 12 is equals a 0.5%. Got to be careful about that. What's a 0.5%? It's like 0.5%. And how do you change a percent into a decimal? Well, let's take the decimal and move it 2 places to the left, right? So 0.5% would be 0.005, just in a bare decimal. So that's where I got this. Of what number? Now, it's not very difficult. A little bit of arithmetic. Found the missing number. Let's take a look at 42. Okay, I'm going to read this out of the book. A salesperson's weekly paycheck is 15% less than her coworker's paycheck. So her paycheck is 15% less. Now, see if you can tell what in the world I'm talking about up there on the top. I don't know, I must have been stuck on A this day. Certainly X is just fine. If your thing is to use Q, I don't care. But anyway, I said, all right, let's say the salary of this particular worker, I call A, says, or the one that, this is actually her coworker. I've got these labeled wrong. This is the coworker. Then wouldn't she be 85% of the coworker? So I did a little twist. If she's 15% less, doesn't that make her 85%? So I wanted to see if you understand. That's a little easier than dealing with a subtraction problem. Okay, so she's really this one right here. This is the girl that's writing the problem, and she says she's not getting paid as much. Okay, then it says, what? Second sentence, the two together total $645. So then I just took the two, added them together, set it equal to 645. I never finished it, but that would be pretty easy, wouldn't it? Just divide both sides by 1.85. Now, when I get done, what will the, I really didn't finish, there's a couple steps I left off of here. This is some other problem down here. Sorry about this. But I really left a couple things off. I could easily solve for A here, right? What will I have found there? The friend's salary, yeah, the coworkers. And then to find hers, I really got to multiply that by 0.85. Or I could take the answer here and subtract it from 645. Either one. They should both work. In fact, that's a good check. Do it both ways and see if you get the same number. If you do, you are positive you've got it. Okay, I want to do a mixture problem now. I'm not ready for the assignment yet. Okay, so let's start with some mixture here. Find a good one. Or A1 anyway. By the way, 11 through 21, do you see what they're asking you to do in that section in the book? It's not even a full problem. They're saying, can you write this in math symbols? You don't even have anything to solve. You know, like 11, the sum of two consecutive natural numbers. How would you write the sum of two consecutive natural numbers? Well, if we call one of them x, then what would the other one be? X plus 1. And then how would I write the sum of those two? X plus 1. Done with that one. And of course that could be simplified too. What's x plus 1? Yeah, but I think I would, because of the way the problem is stated, I actually like the answer for number 11, x plus 1. They want to just see if you can translate. I'm still looking for mixture. Ah, here they come. Yeah, how about 72? Okay, there's a whole bunch of them on page 107. All right. So we got a forester mixes gasoline and oil to make 2 gallons of a mixture for his 2-cycle chainsaw engine. The mixture is 32 parts gasoline and 1 part 2-cycle oil. So they have to be in a ratio of 32 to 1. Or in other words, you put in what? 1/32 as much oil as you do gasoline. Okay. The question is, how much gasoline must be added to bring the mixture to 40 parts of gasoline and 1 part oil? Okay. Well, let's see what we got here. We have gasoline and oil. So we have 2 categories. To make 2 gallons of a mixture for... So he wants to make 2 gallons total. Let me just not write that down. And it turns out that the mixture is 32 parts gasoline and 1 part oil. So whatever amount of oil he uses, I'll just call that X. He uses 32 times as much gas, right? And when you add those 2 up, I don't know if total's quite the right word, but total, yeah, the quantity he gets at the end when he adds them all up in a mixture, in the first example is 2. Okay? Now, the rest of the question says, how much gasoline must be added for 1 part oil? Well, and we're supposed to come up with what, 40? What was that last part? How much gasoline must be added to bring the mixture to 40 parts gasoline? And I got to think about this one. So anyway, right now I've got 32x plus x equals 2. And let me just figure that out. That's what? 33x equals 2. So x equals 2/33. So in other words, that's a pretty tiny fraction of a gallon. That's how much oil he used for this, right? Does that make sense? Now, how much gas should he add so that it becomes 40 parts gasoline? Okay. So if I have 40 parts gas, wouldn't that be 40 times this? And what would that be? That's supposed to be a dot. So there's how much gas he used. Yeah. Let me just get one more time. So it's supposed to be 40 to 1 in the end, a ratio. Okay, so how much gas should he add? Yeah, I'm sorry, I'm having a little trouble setting this one up. Let me think here. Usually my chart works real nice. Didn't work real well this time. So I think what they're saying is you use the same amount of oil, but you add to the gas, and they never. All right, so that would be like. Yeah,
Let me,
It'd be like 40 minus 32. So for how much was it?
yeah, we could get to the addition afterwards. Let me just come back to this one. I'm sorry. I'm just not doing well on this one. Let me try a more conventional mixture, and then we'll do a couple of them. We'll come back. I'll get this one, maybe if nothing else next time. All right, let's do, how about 73? Yeah, this time, the grocer mixes peanuts and walnuts. Okay, so we have two categories. And then we've got the rate, which varies. The rate for the peanuts is $2.49. And the amount for the walnuts, $3.89. Okay. We want to make 100 pounds. So this is the number of pounds in this next column. And we got to have a total down here. And we want this to be 100. Okay, 100 total. And we want it to come out to $3.19 per pound. $3.19 is going to be the rate. Okay, well, what is, the first thing we want to point out here is, let's just say the number of pounds of peanuts is X. Then wouldn't it be true that the number of pounds of walnuts would be 100 minus X? Because, I mean, if you have 100 total and you've already used 20, then it's only what? How much is left? 80. So it's got to be the subtraction. All right, then out here is what? The total cost? I don't know quite what to call it. And how do you get the total cost? You take the number of pounds times the rate. So what is X times 249? 249X. What is 389 times the number of pounds? Well, what's 389 times 100? 389. But then I also have to do this derivative property, and I have to do negative 3.89x. Okay. So now I got my two individual costs, and when I'm all done, it should be the sum of those two, right? So one way to write the cost total is 249x plus 389 minus 3.89x. What's another way to write the total cost? Wouldn't it be 319 times 100? Yeah, from the given information. So there's your equation. In effect, we just found, I forgot to move the decimal, excuse me. So in effect, a lot of these mixture problems work like this, where the idea is to find two ways to get the same thing. One way is add them up, and that's what I did over here. The other way is follow the formula. Rate times amount equals total cost. Well, now we have an equation. Now we should be able to proceed. This is generally the less hard part of it. So what should we do? Let's combine the x terms. What's 2.49x minus 3.89x? I believe that's right, isn't it? Yeah, if you add 40 cents, 149 onto 140 onto 249, you're going to get 389. Okay, now let's subtract 380. We want to get the x alone, so let's subtract 389 from both sides. Of course, we're going to get a negative, aren't we? Now, you shouldn't be shocked here, because you see how we're going to end up with a negative divided by a negative, which truly is going to be a positive. That's a relief, because you sure can't sell a negative number of pounds of peanuts. Okay, so when you divide both sides by negative 1.40, what do you get? Anybody have that divided? 50? Thank you. Now, we're not quite done. We just found out how many pounds of peanuts? 50. Well, how many pounds of walnuts? 100 minus 50. So in this case, it's 50 of each. Now, let me ask another thing. And you know, here's another way we could have figured this out. Look at 319, the target price. Look up above. Is 319 exactly halfway between 249 and 389? Yeah, that would have told us we need an exact half mixture. But what if this wasn't halfway? That shortcut wouldn't have worked. So, you know, we really did it the right way, and this way would have worked no matter where that value was. So let me just write down 50 pounds peanuts, 50 pounds walnuts. And that really would give us a $319 amount and would have satisfied what the requirements of the problem were. All right. How about, let's work on number 71. Yes?
So before we go on, would
Yes.
it be wrong to set this problem as a ratio and have the cross multiplying and dividing them to do it?
No. I just found, I don't know, in the past that this works well, but that doesn't mean it's the only way. Let me show you a second example. 71. 100% concentrate is to be mixed with a mixture having a concentration of 40%, and the overall goal is to get 55 gallons of a mixture with a concentration of 75%. How much of each mixture should we put in to have this happen? So you got the idea. We got two types of liquid available. We have a 100% concentrate, which I'll just label that way. By the way, that means it's what? Not diluted at all. You could also say what? Pure. They didn't say what we're dealing with here, but you know, if it's orange juice, it's pure orange juice, you know, whatever. And the other one is what percent? 40%? So those are the two types of liquid we have, okay? And it's pretty obvious what the rates are, isn't it? This one is a rate of 1, or 100%, and this one is a rate of 40%, and 0.40. So, I mean, that's obvious. And then we've got, what? Number of gallons, the amounts, and we know what? For a total down here, or overall mixture, we know that we want to come up with, what did they say, 55 gallons, I believe? So I'm going to put a 55 down here on the bottom. Okay. And so, I don't know, which one do you want to call X? Doesn't matter. Somebody can pick it. Okay, well, if we call that X, then wouldn't this one have to be called 55 minus X, so that they total 55? And what else? I'm missing one thing yet. Oh yeah, the overall concentration is supposed to be a 75%. So they're telling us this number right here. Okay, so, well, if I take the rate times the number of gallons, I should get what? I'm going to call it amount of, they never told us what it is, so I'm just going to say amount of concentrate. Okay, well, 1 times X is, that's a tough one. And then I got to take 0.40 times the quantity, 55 minus X. And what is that, 22? Somebody check that for me. Is that right?
It is.
Thank you. So 22 minus 0.40x. Okay, and now here's the key again. In this box, there are two ways to get that answer. One way is to literally just total these two guys, and the other way is to multiply these two guys. And that's your equation. So on one side, just let me finish, I know it's toward the end. I add the columns, and that's this part. And on the other side, I simply multiply across the bottom. Let's do that. What is 75% of 55?
41.25.
Thank you. We got our equation. Now, I'm not going to take the time to finish this right now, but it would be easy to solve this for x. But that won't be the whole thing, right? That'll only tell you how many gallons of the pure stuff.
That's what I look for though.
Okay. It would be easy to find the other, wouldn't it? Just be whatever that is subtracted from 55. I want to do some more. I want to come back and do that other mixture problem. And so what I'm going to do is, we'll go with this assignment, but that's the every other odd deal, 159, ... But I'm gonna have you just kind of quit when you get to don't go past 65. Okay, now that might not be the last one, but I think don't go past 65 because there's some mixture problems after that, and I didn't quite get that done. Thank you. So 159, every other odd. Do 1, skip 3, do 5. But don't go past 65.